Welcome all children. As earlier we have covered the topic doping in semiconductors. So let us revise that term doping. Doping is a process in which we add impurities to semiconductors, and on adding the impurities to semiconductors, their electrical conductivity increases. So on the basis of the type of impurity added to semiconductors, semiconductors can be divided into two types. So the first type of semiconductor is N-type semiconductors, and they are also known as electron-rich impurity. It means that to the semiconductors we are adding some elements which are rich in electrons. As you all know, silicon and germanium are semiconductors and they belong to group 14. So, when we talk about their groups, they are of group 14 and they have 4 valence electrons. Suppose I talk about this silicon atom. Now this silicon atom is having 1, 2, 3, 4. 4 electron in its valence shell. Now 1, 2, 3, 4. 4 neighboring atoms are surrounding this silicon atom. Then each silicon atom is giving its electron to this central one silicon atom. Now it will form 4 covalent bond by the sharing of electrons. 1, 2, 3, 4 electron from this silicon atom and 4 electrons from the neighboring silicon atoms. So thus this will form 4 covalent bond with the neighboring atoms, that is by sharing of electrons. It means they have 4 valence electrons. Now when we talk about N-type semiconductors, what we'll be doing is we will be doping group 14 elements with group 15 elements. Now group 15 elements are phosphorus or arsenic. What we'll do, we'll add phosphorus or arsenic to silicon or germanium atom. Now group 15 elements have 5 valence electrons. So when we talk about this, it is N-type semiconductor. Now this is generally silicon structure, silicon atom we showing. Now if we remove one silicon atom from here and put group 15 element like arsenic over here, then arsenic is having 5 valence electrons. So 1, 2, 3, 4 and 5th electron of arsenic is here. Now this arsenic is surrounded by 4 neighboring silicon atoms. Now this silicon atom is giving 1 electron, this also giving 1 more electron, this 1 electron, this is also giving 1 electron. So with 4 electrons of arsenic, the 4 neighboring silicon atoms will form covalent bonds, and this electron is left free, which is extra. So this electron is the mobile electron. So this electron tend to move in this structure, in this type of semiconductor. So when this electron is delocalized due to doping, then due to the movement of this electron, there is electrical conductivity that is observed in N-type of semiconductors. So as the conductivity increases in semiconductors due to negatively charged electron, that is electron-rich impurity, it is called N-type of semiconductor. Now next type is P-type semiconductor. So when we talk about P-type semiconductor, we will be adding to group 14, that is silicon or germanium, electron deficit impurity. We'll be adding to group 14 what? Group 13 elements like boron or aluminium. group 13 element. So 3 electron they'll be having in their valence shell. Now what will happen? You look at this structure. This is general silicon structure. So if you remove a silicon atom from here and put a boron atom over here, then 1, 2, 3, 4. These 4 silicon atoms will donate 1 electron, 1 electron, and like this silicon has donated this electron, this silicon atom has donated this electron, this silicon atom donated this electron, and this silicon atom has donated this electron. But boron, that is belonging to group 13, will have 3 valence electrons, 1, 2, 3. So 1, 2, 3 covalent bonds are formed, and here 1 boron electron would have come, but as it is electron deficient, so in place of 1 electron, a hole is left. A hole is left with no electron. So as this hole is having no electron, therefore it is a positive hole. Now what happens? Its neighboring electron will feel bad for this boron atom. It will feel that, oh, this place is vacant, I should help this one. So this electron will move into the hole, so leaving a vacant space over here, leaving a hole over here. Now the next electron of silicon will feel bad for this hole, so this electron will move here and will leave a hole over here. So in this way, this hole will be moving in this whole structure, whole atom of now in this semiconductor. So this hole is a positive hole, and this positive charge is roaming in this structure. So it is due to this positive charge. It is due to this positive charge that a charge is being carried, and it is its electrical conductivity. So as in silicon or germanium, they are doped with electron deficit impurities. These are called p-type semiconductors. And in this type of semiconductor, hole moves through the crystal like positive charge. So it is due to the movement of the positive charge, that is, you can see the electrical conductivity in them. Now next one is, if you apply electric field to this semiconductor, if you apply electric field, then the electrons will move towards the positively charged plate, opposite charges. Electron will move to positive charged plate, and electron holes which are positively charged will move to negatively charged plate. So this is what the two types of semiconductors are. Now next topic is application of N-type and P-type semiconductor diode. What are the applications of these two type of semiconductor diode? So for if we want to know the applications of these two type of semiconductor diode, then firstly we should know what is a diode. Diode is a combination of N-type and P-type of semiconductor. When you combine N-type and P-type of semiconductor, you get a diode. And this diode is used as a rectifier. Diodes are used as a rectifier. Now there are two types of transistors, NPN and PNP. As you can see, these are two type of transistors, and in this you are sandwiching a layer of one type of semiconductor between two layers of the other type of semiconductor. Here a layer of P type of semiconductor is sandwiched between two layers of N type of semiconductor, and here N type of semiconductor is sandwiched between two layers of P type semiconductor. So you get NPN and PNP transistors. Where these transistors are used? These are used to detect or amplify radio or audio signals. You can detect the radio or audio signals. Now next topic is photodiode. Next application is in photodiodes. As the name indicates, photo means light And diode, you know, when one layer is one type of semiconductor sandwiched between the other type of semiconductor. So diodes, these are those diodes which are capable of converting light energy into electrical energy. So photodiodes are those which convert light energy to electrical energy. Now where they are used? They are used in solar cells. Solar cells they are used. And the material used in solar cell is amorphous silica. So that's all for today. Thank you and have a nice day.